Chapter 3, Lesson 1, Constant Rate of Change. Essential question, why are graphs helpful? Vocabulary, linear relationship, constant rate of change. Real world link, music. Marcus can download 2 songs from the internet each minute. This is shown in the table below. At 0 minutes, he has 0 songs. At 1 minute, he's downloaded 2 songs. At 2 minutes, he has downloaded 4 songs. At 3 minutes, 6 songs. And at 4 minutes, 8 songs. So we're going to compare the change in the number of songs, y, to the change in time, x. What is the rate of change? Well, the number of songs increases by 2. I know that because it goes from 0 to 2, 2 to 4, 4 to 6, 6 to 8. So it's going up by 2 every time. And the time increases by 1. So this means that there are 2 songs per 1 minute. And again, using my table, going from 0 to 1, 1 to 2, 2 to 3, 3 to 4, I am adding 1. Number 2, graph the ordered pairs from the table on the graph shown, label the axes, then describe the pattern shown on the graph. Well, I personally am going to label the axes as my first step, then graph the ordered pairs. So my x-axis is going to be the time in minutes. The y-axis is going to be the number of songs. So time in minutes. Then the y-axis is number of songs. So my first ordered pair is 0, 0. So I'm going to plot that. My second ordered pair is going to be 1, 2. Over 1, up 2. My third ordered pair is at 2, 4. To the right 2, up 4. My fourth ordered pair is 3, 6. So to the right 3, up 6. And my last ordered pair is at 4, 8. To the right 4, up 8. And I'm going to connect my points. Describe the pattern shown on the graph. Well, the points appear to make a line. Whoops. Wrong tool. The points appear to make a line. As you could tell, they make a line because I drew a line through them. A linear relationship. Relationships that have straight line graphs, like the one on the previous page, are called linear relationships. Practice saying the word linear, not linear, linear. Notice that as one number of song increases by 2, the time increases by 1. So the number of songs, y, goes up by 2 each time, from 2 to 4, 4 to 6, 6 to 8. And the time increases by 1, 0 to 1, 1 to 2, 2 to 3, 3 to 4. So the rate of change is 2 divided by 1, which means there are 2 songs per minute. The rate of change between any 2 points in a linear relationship is the same or constant. A linear relationship has a constant rate of change. Instead of needing to write out constant rate of change each time, we're going to abbreviate it constant rate of change, with the first letters of each word. It spells the word crock. We won't ever say the word crock. We'll always say constant rate of change, but that is a nice abbreviation. Now, if anyone is wondering, could you make rate of change into rock, meaning ROC? Absolutely. Just make sure you're saying rate of change. Example number 1. The balance in an account after several transactions is shown. Is the relationship between the balance and number of transactions linear? If so, find the constant rate of change. If not, explain your reasoning. So the number of transactions, well, we're going from 3 to 6, 6 to 9, and 9 to 12. Each time we're adding 3. So far, this has a constant rate of change, at least for the number of transactions. But we have to have the same values for our balance then. Well, if you go from 170 to 140, 140 to 110, 110 to 80, we are decreasing by 30 each time. So we're taking away 30. So to find the constant rate of change, that means we have to find our balance to our transactions. So if we are decreasing by $30 for every 3 transactions, that reduces down to 10 divided by 1, which is reduced down further to 10. So that means that it's negative $10 per transaction. So this is your constant rate of change. This is where the abbreviation comes in. So essentially what that means is each time you have a transaction, you are making a withdrawal of $10. That's the same thing as saying negative $10 per transaction. It is a $10 withdrawal. Got it? Let's do these problems to find out. So time in minutes, we go from 5 to 10, 10 to 15, 15 to 20. Each time we are increasing by 5. Next, the temperature in degrees Fahrenheit goes from 95 to 90, 90 to 86, 86 to 82. The first change is by 5. The second one is by 4. And the third one is by 4. Well, because all of these are not the same, we go negative 5, negative 4, negative 4. That means that this does not have a constant rate of change. So, no, there is no constant rate of change. So for letter B, let's go ahead and find out for this one. I'm going to make a table of values. I'm going to say number of volunteers to time in minutes. Number of volunteers, well, it appears that that is 8. And at 8, there are 70 minutes. And then if there's 16 volunteers, then that is 60 minutes. 24 volunteers is 40 minutes. And those are all of the ordered pairs that we have. So from 8 to 16, we're adding 8. From 16 to 24, we're adding 8. So to get from 70, to get from 70 to 60, oh, my apologies, that should be 80. To get from 80 to 60, that's subtracting 20. To get from 60 to 40, that is subtracting 20. So this means that it is negative 20 divided by 8, what could be simplified down, if you divide both the numerator and denominator by 4, negative 5 divided by 2, which is negative 2.5. That means that it is negative 2.5 minutes per volunteer. So this is your constant rate of change. Let's continue. Proportional linear relationships. In words, those are two quantities, A and B, have a proportional linear relationship if they have a constant ratio and a constant rate of change. So symbols, B divided by A is constant, and the change in B divided by the change in A is constant. To determine if two quantities are proportional, compare the ratio B divided by A for several pairs of points to determine if there is a constant ratio. So example number 2. Use the table to determine if there is a proportional linear relationship between the temperature in degrees Fahrenheit and a temperature in degrees Celsius. Explain your reasoning. So in degrees Celsius, 0 to 5, 5 to 10, 10 to 15, 15 to 20, you can see that you're going up by 5 each time. In Fahrenheit, it goes from 32 to 41, 41 to 50, 50 to 59, 59 to 68. We're increasing by 9 each time. So the rate of change is constant. This is a linear relationship because it has a constant rate of change. Now, the constant rate of change is the change in degrees Fahrenheit, which is adding 9, and the change in degrees Celsius, which is adding 5. So that is going to give us 5 nines for the constant rate of change. So to determine if the two scales are proportional, express the relationship between the degrees for several columns as a ratio. So you see degrees Fahrenheit divided by degrees Celsius. 41 divided by 5 is 8 and 2 tenths. 50 divided by 10 is 5. 59 divided by 15 is about 3 and 9 tenths. So these ratios are not the same. As you reduce them down, 8 and 2 tenths, 5 and 3 and 9 tenths do not equal the same thing. So it does have a constant rate of change. However, it does not have the same ratios. So this means it is not proportional. In order for it to be proportional, it must have the same ratios. So if you graph the points on the coordinate plane, then connect them with the line. The points appear to fall in a straight line, so the relationship is linear. The lines connecting the points does not pass through the origin, so the relationship is not proportional. In order for it to be proportional, it has to pass through the origin, be a straight line, and have a constant rate of change. Well, this is a straight line and has a constant rate of change, but does not pass through the origin. Got it? Let's do this problem to find out. We're going to use the table to determine if there is a proportional linear relationship between the mass of an object in kilograms and the weight of the object in pounds, and explain your reasoning. So let's start with the weight in pounds. It goes from 20 to 40, 40 to 60, 60 to 80. So that means that I'm increasing by 20 each time. The mass in kilograms goes from 9 to 18, 18 to 27, 27 to 36. Each time I'm increasing by 9. So when I make my constant rate of change, so if I go back up to the previous problem, I want to make my constant rate of change. So in this case, I had the change in degrees Fahrenheit divided by the change in degrees Celsius. So for this one, I'm going to find the change in mass, which is in kilograms, divided by the change in weight, which is pounds. Well, the change in mass in kilograms is 9, divided by the change in weight in pounds, which is 20. Now I can't reduce that down anymore, so that's going to be my answer for my constant rate of change. So this one has a constant rate of change. And again, I know that because each time my mass goes up by 9, my weight goes up by 20. So far, if we have the 3 requirements of passes through origin, the second one has a straight line and has a constant rate of change. Well, I know that I have the last one so far. My constant rate of change is equal to 9/20. Then I want to determine whether or not it is a straight line. Well, if it's increasing by the same amount every time and it has a constant rate of change, it is going to be a straight line. The last one is to see whether or not it passes through the origin to determine if it's a linear relationship. Well, if I have 20 and 9, and I'm making my ordered pairs down, I'm making an extra table, I have pounds and I have kilograms. Well, if each time I go to the right, I am increasing by 9 kilograms and I'm increasing by 20 pounds. Well, if I go in the opposite direction and I decrease by 20 pounds, that gives me a 0. If I decrease by 9 kilograms, that gives me a 0. So the origin's ordered pair is 0, 0. Oh, let me change the color of this. 0, 0 is my ordered pair. I'm sorry, is my origin. So does it pass through the origin? Yes. So there is a proportional relationship because it has a constant rate of change, is a straight line, and passes through the origin. Great job.